So polynomial functions then. So let's define what a polynomial is. So a polynomial is basically, it's an algebraic expression where we have all the terms and the powers of x are always integers, or 0 of course, could be x to the power of 0, because constants are polynomials as well. You notice we say polynomial n is not equal to 0. Well, that's because we call this a polynomial of degree n, and n is always the highest power. So it's trivial, but if Pn was equal to 0, then it wouldn't be there, and the highest power wouldn't be n. So it's not really a big deal, it's just for the sake of the definition. So the order is the highest power. So coefficients, just like all other algebra, they're the numbers that go in front of the unknown. Index, exponents, just other words for power. Degree, as I said, is the highest power in our polynomial. And we call it a polynomial of degree n. So a quadratic would be a polynomial of degree 2. So that's the highest power in there. A leading term. Now be careful with these next two. Leading term is the actual term with the highest power, whereas the leading coefficient is just the coefficient. So you don't have the x to the power of whatever. So make sure you read the question carefully. Make sure you know which one they're asking for if they're asking for those. And monic just means that the leading coefficient is 1. It has to be positive 1. So negative 1, no good. Got to be positive 1. Now, if we make a polynomial equal to a number, usually 0, we call it a polynomial equation. And if it's equal to another pronumeral, probably going to be y, then it's the polynomial function. So roots are solutions to the equation, whereas zeros are the values of x that make the polynomial 0. You might recall some of these definitions are the same as when we looked at, we talked about it in quadratics, wasn't it? So of course a quadratic is a polynomial. So that's why a lot of these definitions are the same. And that end up being the x-intercepts of the graph that we draw. So 5x cubed minus 7x to the power half minus 2. Hands who thinks that this is a polynomial. Who's going to go for it's not a polynomial? Oh, okay, why? So yeah, you can't have a half as a power in a polynomial. Part B. Have a look at part B. Is it a polynomial? Yes or no? No is correct. Because in this case, I could rewrite it as 4, but then x squared plus 3 to the power of negative 1, and then you've got a negative power. So you can't have negative powers in the polynomial. What about if we flip that? X squared plus 3 over 4, what do you think? Polynomial? Oh, good, very good. So yes, it is. And it would actually be a polynomial of degree. So yes, degree 2. And the number 7 by itself, is that a polynomial?
Yeah.
Yes, it is. And it's a polynomial of degree 0, because technically it could be 7x to the power of 0. All right, let's see. This expression here, let's work out, is it monic? And what's its degree? Okay, yeah, because look, when you expand it out, oh, look what happens. The 8x to the power of 4, but you've also got a minus 8x to the power of 4. So in fact, the leading term is x cubed, but it's 1x cubed. So yes, it is actually monic. So it's monic of degree 3. All right, well that'll do us for today. 10A.